Okay, so in this video we're going to talk about solving 3x3 systems of equations. And what I mean by that is there's going to be 3 equations and then 3 variables. So we're going to have an x, a y, and a z. Okay, so we're going to start off with a more basic example. And in this more basic example, the third equation is going to be very helpful. So if you look at my third equation, I have 3x equals 3. So if 3x equals 3, if I divide by 3, then x is going to be equal to 1. So in this more simple example, the third equation is basically going to give me the value of one of the variables. Then if I look at the second equation, I have 2x plus y equals 5. So the third equation told me that x was 1. The second equation only has 2 variables in it, x and y. If I know that the x value is 1, then I can substitute a 1 in for x and solve for y, because there's only 2 variables. So if I know one of them, then I'm good. Last but not least, so we know x equals 1, we know y equals 3, but I also need to know z, and I have one equation left, so we have x plus y plus z equals 9. If I know x is 1, and I know y is 3, then I can substitute 1 for x and 3 for y. And that lets me know that z equals 5. So my answer here would be x equals 1, y equals 3, and z equals 5. All right, so this one is a little more involved, as the example says. So if you look, none of the equations give me the value of one of the variables. But if I look at the second and third equation, I only have 2 variables. So what I'm going to do is I'm going to only use the second and third equations here. So I'm going to look at 2x plus y equals 0 and x minus 3y equals 0. And I'm going to eliminate one of the variables here and solve for the other. So if I look at my, doesn't matter which one. Oh, that's not 0. That's negative 14. If I look at my x variables, I have 2x and x. So if I want to eliminate x, I can multiply this bottom equation by negative 2. Because if I multiply the bottom equation by negative 2, it's going to turn my x value into negative 2x. So this becomes negative 2x plus 6y equals 28. Because I just multiplied all 3 pieces by negative 2. Then I'm going to bring down the first equation. So 2x plus y equals 0. Then when I add these together, when I'm using the elimination technique, my x's are gone. They're eliminated. And I have 7y, because 6 plus 1 is 7, equals 28. So y equals 4. So if I eliminate x out of the second and third equation, I figure out that my y variable is 4. Then, if I go back, I know that 2x plus y equals 0. So I know that 2x plus 4 equals 0 because I know my y value is 4, so I'm replacing the y with 4. And then you subtract 4, divide by 2, also known as doing a little algebra. You do that, and then you figure out that y equals 4. Then we know that x equals negative 2. And if I know x and y, I can go back to my first equation that has all 3 variables, and we can do x minus y minus z equals negative 7. So I know my x is negative 2, I know my y is 4, and I don't know my z. Then negative 2 minus 4 is negative 6. Oops. So I get negative z equals negative 1. I don't care what negative z is, so I'm going to divide by negative 1 because I do, oops, I'm writing in docere. Z is equal to positive 1. So the first example we did gave us the value of one of the variables, and we just substituted it in from there. This one, it's not as straightforward, but the second and third equation only have two variables. So we're going to eliminate one of the variables in the bottom two equations to solve for y or x, depending on what you eliminated. Then we're going to use either the second or third equation to solve for the one that we didn't eliminate. So I eliminated the x value in the red ink and solved for y. Then in green ink, I went back to the second equation, and since I already knew y, I plugged in 4, and that let me solve for x. And then in purple, I already knew x and y, so I went to the first equation, plugged in x and y, and then solved for z. One more. All right. This is what our work we're going to call triple elimination. Names aren't that important. But this is going to be as bad as it gets. Okay, so here we go. With triple elimination, all three equations have all three variables. So what we need to do is we need to use the first two equations and eliminate a variable. Then we need to use the bottom two equations and eliminate the same variable. So here in purple, I'm going to use the top two equations. So I'm going to use the top two equations, and if I look at my x's, they don't automatically eliminate. My y's don't automatically cancel out. But if I look at my z's, I have plus z in the first equation, and I have minus z in the second equation. So if I add these equations together, I get 3x plus 4y, my z's go away, equals 28. Okay, so I used the first two equations, and I eliminated z. Now I go to the second and third equation, and since I eliminated z to get this equation, I need to eliminate z again to get a separate equation. And if I look, my z's also cancel out nicely here. So I have 5x plus 2y, my z's are gone when I add these equations together, equals 14. So now, after I've eliminated z twice, I have these two equations. So now I'm looking at 3x plus 4y equals 28, and I have 5x plus 2y equals negative 10. All right, so now I have these two equations, and I'm going to use elimination with my red equations now. So let's just eliminate y's. The reason I'm choosing y is I have 4y in the top and 2y in the bottom. So if I multiply my second equation here by negative 2, I'll be able to eliminate y. So my second equation is going to turn into negative 10x minus 4y equals 20. And my first equation we're just going to bring down. And when I add these together, I get negative 7x, my y's are gone, equals, what is that, 48? I noticed if you look in red right here, I copied down negative 10, and I have no idea where that came from. Oh yeah, I do. It's right there. But this should say 14 because I'm copying down the equations that I have highlighted. So that should say 5x plus 2y equals 14, which is going to change this to negative 28 because I knew that 48 didn't look good for us. So my bad. This is correct now. So sorry if you're writing in pen. But now we have negative 7x equals, and when I combine these, it's 0. So when I divide by negative 7, my x value is 0. So in purple, we used the first two equations and eliminated z. Then we also used the second and third equation and eliminated z again, which gave me the highlighted equations. Those highlighted equations we then moved over to the middle in red ink, and then we're going to use elimination on these 2 by 2, so these two equations that only have two variables. And that's going to let me solve for x, and then I'm going to go use these same equations that we just used, and I'm going to choose one of them. I'll just choose the top one, 3x plus 4y equals 28. And I know that my x is 0, so I'm going to plug in 0 for x, and then solve for y. So 0 means my x's are gone there, and my y value is 7. So now that I've eliminated z in both equations, that let me solve for x and y. And then the last thing we need to do, as if this wasn't enough, is we need to solve for z. And where am I going to do that? I'll do it down here. We need to solve for z, so we know that x plus, and you can pick any equation you want. The top one I think is the simplest, but if you want to use a different one, you can. I know that x is 0. I know that y is 7. So if we subtract 7 from both sides, and I'm running into Doceri, so I'm just going to move this up here. So z equals 4 minus 7 is negative 3. So in this last method, and I promise you this is as bad as it could possibly be for our purposes, you eliminate the same variable in the top two and bottom two equations. Then that gives you the red. Using the red, you can solve for two of the three variables, in this case x and y. And then once we know two of the variables, you just plug in into the simplest equation. I use the first one to solve for the third.